Question number 8, systems of equations and finding their solutions. So Joe and Bob are traveling on a trip. So far, Joe has traveled 211.25 miles in 3.25 hours. Bob leaves half an hour after Joe, and so far Bob has traveled 112.5 miles in 1.5 hours. Assume they both travel at constant rates. Let X represent the number of hours that have elapsed since Joe started traveling. Let Y represent the number of miles traveled. Write a system of equations that represents the distance each of them has traveled since Joe left. Assume they both maintain constant rates and make no stops. So if you notice, this entire problem, for part A, it just says determine the solution, and we should have a point here. There's another multiple choice question about it, but for the most part, the system is all on you. You're going to have to figure out what their system is and solve it, and none of the rest of that is actually getting graded. So the first thing we're going to need to do is determine both of their speeds. So we've got Joe, and Joe traveled 211.25 miles in 3.25 hours. That means that Joe, if I do this divided by this, Joe is going 65 miles per hour. Now, Bob, on the other hand, Bob has traveled 112.5 miles in 1.5 hours. If I do 112.5 divided by 1.5, I find out that Bob's a little speed demon and he's going 75 miles per hour. So far, the two equations for Joe and Bob is y equals 65x for Joe and y equals 75x for Bob. However, you will recall that Joe left first. He actually drove a half hour before Bob started his trip as well. So Joe has a head start. So if he's going 65 miles per hour and he's driving for 30 minutes, that would be half an hour. So what I can do is say 65 times 1/2, and that's going to give me how much of a head start Joe has, and that's actually 32.5 miles. So on Joe's equation, on the 65x, I need to add 32.5 because he had a bit of a head start on Bob. I don't have any head start for Bob, so if I just want to do plus 0, I can do that. So both of these are in slope-intercept form, so I can go ahead and take them and set them equal to each other. So I'm just going to go and do this at the bottom of my page. So 65x plus 32.5 for Joe equals 75x for good old Bob here. So to solve this for x, I would need to subtract 65x from both sides to get my x's all on one side. Have 32.5 on this side. Over here, 75 minus 65 would give me 10x. I would then divide both sides by 10 and find out that x is equal to 32.5 divided by 10 is 3.25. Well, if you recall, x was standing for our number of hours after one of them had left. So Joe left first, so it's after Bob leaves. Y is how far they've gone, so their distance, in this case in miles. So what I have is that so far, I know that they're going to meet up at 3.25 hours, but I need to know how far they will have gone at that point because that'll be the other part to this solution. So I know the 3.25, but I don't know the y coordinate yet. Well, of the two equations, I'm going to argue that Bob's is a little simpler because it's just 75x. But now that I know what x is, I know it's 3.25, I can just multiply those two numbers to find out how many miles they're going to be at when they meet up. When I do that, I find out that they're going to meet at 243.75 miles. So that is the y coordinate of my solution. So the solution is 3.25 hours, 243.75 miles. Now down here, what does the x coordinate of the solution represent in terms of the context of the problem? Well, if you remember, x is the number of hours, and we have determined that that is the number of hours after Bob began his trip when he and Joe will have traveled the same distance. Now, these all look very similar, but what I just said is letter B. It has nothing to do with their speed, so that eliminates both A and C. And since Joe began first, it's the number of hours after Bob began, who is the one that did not have a head start.